Hello, Keith Rucker here at VintageMachinery.org. Well guys, we're back on the Landis Surface Grinder project that I've been working on now for a little bit of time, trying to fix an issue. We've had an issue where a set screw came loose in this pulley, which caused us to spin on a shaft. It unfortunately made the shaft a little bit undersized, a little bit tapered, and also made the bore in this hub a little bit oversized, so it's not fitting right. We've already in a previous video gone in and fixed the shaft. We had to basically grind a little bit off of that, get it running true again. Now on the pulley, we got to get this thing fixed. So let me take this over here, zoom in, and show you what we're going to be doing today. So again, this bore here is actually a couple of thousandths, so we're supposed to be 3/4 of an inch. It's actually a little bit oversized and tapered, but then also because we had reduced the diameter on the shaft to true it up, it's now definitely oversized. So again, the plan here is we're going to just come in here, we're going to bore that entire hub out, oversized, and then I will make a bushing to go down in here that will get it back down to the correct size. We'll broach that out to put the keyway in and so forth. Now, one thing I will note on this is that the shaft goes in about halfway depth, and then it's actually bored out to 1 inch on this side. Not exactly sure what that extra clearance was done, but when we make our new bushing, we will replicate that. We will put that into the new bushing design. But step one on this is we're going to take this over to the lathe, get this pulley chucked up in the lathe, mounted in there, and we've got to get it running true both on the outside surface as well as on this inside surface so that it's not wobbling. It's got to be running true in diameter and also not wobbling. So once we get that set up on the lathe, we will come in and bore that out. Take about 1.5 thou out here. All right, that looks pretty good. And back in here, we're about the same as we were a while ago. Let's see if I can. That's about as good as I can get that. So I think we're good. We got it trued up. We're ready to start boring. So we got our boring bar set up now, and just a couple of comments here. You know, you always want to use the biggest boring bar that you can possibly get in the hole that you're starting with. It just makes this bar more rigid. The bigger the diameter of this, the more rigid the bar is, and basically the better job you're going to get with it, particularly if it's sticking out a long ways. So we are limited here, but this is the largest boring bar that I can get in there, and it actually just barely fits, at least when we're starting here. Now, as we increase the size of the hole, we'll have more clearance in there, no big deal. And anyway, we're ready to go. Let's fire up the lathe, turn it on. Pulley looks like it's running nice and true, which goes along with what the indicator read. I'm going to come in here, and we're already touching just a little bit there. I'm going to just make a light pass this first pass through, and let's do it. You can hear that boring bar kind of skipping in there. That's telling me that it's not very true. All right, we got through that first step of the bore. I'm going to go ahead and stop. The back side is relieved out a little bit more, so the first part of this, we won't be making a full cut. We're starting out just a tad over 3/4 of an inch. Like I said, it was just a little bit oversized. We're going to bore this out to 1 inch 200 thousandths, which will give us room for our bushing and still have room for the keyway in there as well. So anyway, we'll just keep doing this until we get up there. So I probably won't sit here and make you watch all this, but we'll do a pass or two and then bring you back when we get close. All right, so we're just a touch under our mark right there. That's what I figured. There was a little bit of spring in there from that last pass, and then we've got the 2000, so that got us right there in there. Within probably about 3 or 4 tenths. I need to go grab I got a micrometer that'll measure tenths. This one won't. So let me get a couple of more snaps in here just to kind of make sure that I'm getting a good accurate reading. Now that we got the bore done, I got the measurements on it. It turned out about, it was 1.201 is basically what the inside diameter. So I was about 1/1000th over what I was shooting for. Again, not a big deal because we're going to make this part, the bushing, fit, where we'll have a nice interference fit. We're going to heat it up and shrink it on there. And according to the Machinery's Handbook, I need about 1/1000th of an inch of interference in there. So we're going to make this outside diameter 1/1000th larger than the bore. So we're shooting for an outside diameter of 1.202 inches, and we're going to have drill a hole through here. That inside diameter needs to be about 0.731, so we'll drill that out and then bore it to size. Only about half of the bore is actually going to fit up onto the shaft. The back half of this is actually oversized. This 1-inch bore on it, so we will turn that part around and bore that other side out a little bit oversized. Not exactly sure what the reason for that is, but that's just the way it is, and that's what we're going to work with. Total length on this part is 2.045, and that's just the actual thickness of the hub over there. So again, that's what we're going to shoot for there. I've got a piece of stock here in the lathe. This is 1.25 inches diameter, so we just got to shave a little bit off the outside diameter to get it down to size. Drill and bore that hole in there. And anyway, let's get started on the lathe turning this piece out. So we got this thing all running true in here. I put my indicator on there. It's in the forge jaws, so it is nice and running true. First thing we want to do is come in here and just face off this front, get a nice surface on here. I've got a mark about how far down I want to turn, and we're going to turn this down. All right, so I'm going to come in here and touch off on the face. Do just a little bit of lube. Face that off. So we're at 1 inch, 250 thousandths roughly is our nominal, and we're shooting for 202, 1 inch, 202 thousandths. So we got a little less than 50 thousandths to take off of that diameter. Again, I got my mark on where I want to go to. We'll take a pad over 20 off, start with. Getting a rough measurement right now, so we're at about 225. Again, we want to go to 202. Take about 18 or so. See where we're at here. I got about 11 thousandths, take off there. Yeah, just about the same on that side. So let's see where we're at now. All right, we're about 202 and a half, 203, about 203 again there, just a touch over. So we're actually pretty good. I think what I'm going to do is just, we've got a little bit of taper, it's a little bit bigger in the back than it is on the front. And I'm just going to take some emery cloth here. See where we're at now. That's about 203, 202 and a half, 202 and a half. So still just a little bit of taper in here. So just a little bit big on this back side, but really it's just in this last little bit. So anyway, I'm gonna polish that a little bit more, and I think we're gonna be good. Not much, just a little bit back here in the very back. I know you probably can't read the micrometer very well, but that's just a tad over 202 and a half. So according to the vernier scale, it's about 7/10. And that's going to be close enough for my press fit. I was shooting for about 202 and a half is what I finally came up with. And those few tenths in there are not going to make a difference. So I'm going to let that, no real heat in there at all, so that should be fine. All right, let me get ready to start getting my bore in here. I'm going now to an 11/16 drill, and this will get us fairly close to what we're shooting for, and we'll go in there and cut the rest of it out with a bore and bar and then ream it. I believe we are to depth. Got my sketch back here of this bushing that we're making, and if you remember from the original, this is the bore down here, the .731. This is what we were shooting for as far as going up on that shaft, but on the back side of this bushing, it actually was bored out to 1 inch. And I'm really not exactly sure why they did that, other than the shaft is only this long, that's going to go up in here. And I think that's just some extra clearance in the back, right? And it's really just clearance. It measured 1 inch, and but I don't think that measurement is critical by any means. So we just got a 1 inch drill bit set up here, and I'm just going to come in here and use that to basically create a counter bore in here. And I've got a mark on here to my depth. The depth of the original was 815 thousandths, and again, that measurement I do not think is critical. So anyway, we just got a mark on here. I'm going to go in that deep and stop, and that should get my counter bore done. see my mark right there. Come on out. So I think we're ready for a press fit here. I got my bushing made. It is ready to go in. Got our counterbore in here. We've still got to take this to the final diameter on the inside. I think what I'm going to do is I'm going to wait until after we get it pressed into the shaft, and then I'm going to remount the whole, or excuse me, the pulley. I'm going to remount the whole pulley over on the lathe. We'll get it running perfectly true. We'll run a boring bar through there to true it up, just in case, you know, this thing, if for any reason, once it presses in there, if it's out in any direction or whatever, by doing that last bore on the pulley, I can straighten that out. If I go ahead and make it the size now, press it in, and say it ends up a thousandth or two out for whatever reason, you really can't go back and do anything about it then. So anyway, that's my game plan. We're going to do that the inside bore mounted in the pulley, just in case. I've got this set up right now where this shaft, or this bushing rather, is about 1/1000th of an inch larger in diameter than the hole. And that should give us a good press fit. I have looked over in Machinery's handbook, and again, for this diameter and these materials, doing a good tight, what they call a shrink fit, they recommend 1/1000th of interference, so that's what we've got. And because we are going to do what I'm going to call a shrink fit, my game plan here is that we're not going to go over and try to just press this thing in at room temperature. What I'm going to do is we're going to take this pulley and we're going to heat it up good and hot, and what that should do is it should make the bore just a little bit larger in diameter. At the same time, I'm going to go take this bushing, I'm going to stick it in the freezer and leave it in there for an hour or two, let it get colder, and again, in theory, it should shrink in size just a little bit, and that should make the press fit go a little bit easier. Now, as far as heating up this pulley goes, you know, I could just go over there and use the torch and get it good and hot. But I really want to heat it up nice and even rather than a flame on here and getting it and heat it up to different temperatures around. So I'm going to do something kind of crazy and something kind of risky and something that I don't really recommend. I'm going to go take this and put it in the oven in the house. Now, the reason this is risky is because if my wife finds out, I'm in big trouble. She doesn't like me putting machinery parts in her oven, but she's not home right now, so we're going to sneak it in there. And I'm going to probably set the oven to about 350 degrees. We're going to bake this thing for a little while until we get the temperature up. And again, hopefully that will allow us to do a true shrink fit on here and get it in there. Now, as far as the cold goes, I'm going to put this in the freezer, and we're going to try to shrink it down a little bit there. You know, ideally, you could use like liquid nitrogen or something like that. That would get it really, really cold and really make a bigger difference. I just don't have access to liquid nitrogen. I don't do enough of this to justify bringing a tank of it into the shop or anything. So we're just going to take it down a little bit. Ambient temperature in here right now, about 75 degrees. So we're going to take it down probably to 32 degrees or a little bit below that. Fahrenheit, of course, there. But that should still shrink it a little bit. We're only got 1/1000th of interference, so we don't need a whole lot. With any luck, I'm going to be able to come in here and we'll just drop this piece right in here, and it won't even require any press. And then as it cools back down or warms back up to ambient temperature, it'll shrink on and be just right. So let's go get this stuff cooling down and heating up. All right, we just pulled it out of the oven. I wrapped it up in some tin foil just in case any oil or grease or anything was in there. And it looks like there was some. Wouldn't accidentally get into my wife's oven. And I'll tell you what I want to do here. So take this off real quick. My infrared thermometer here, my bench is 79.5 degrees, so that's about the ambient temperature. This is up to about 220 degrees right now. Might have left it in the oven a little bit longer. I want to get a measurement on that bore real quick just to kind of see how much it grew. So let's see what we got. It was 1.201 and a half, and we're right now at almost 1.203. So it did grow some, which is good. Pick this thing up over here. And we're going to press it in right there. Now here is my bushing, and it's been in the freezer, and it's showing, that's not right, it's picking up more ambient temperature there. It's saying it's 74 degrees, but it's a lot colder than that. I'm not going to worry about it. Let's see what happens here. We're going to come over here, take this, and just easy peasy goes right in. All right, that is pressed in there. I'm going to let this just sit here and cool down or warm up, whichever way it has to go. But let this get back to ambient temperature, and it should be shrunk in there nice and tight. I've got my pulley set back up over here in the lathe. This is in the 4-jaw chuck, and once again we came in here, we indicated on both this face and the inside face. I've got this thing running to within less than 1/1000th of an inch in any direction, which is about as good as I could get it. Now what I'm going to do is come in here, we're going to bore the hole here, and again the whole purpose of this is I'm trying to get this bore hole where it's running perfectly true with the pulley itself. Now, you know, we bored that in there earlier into the bushing, but you know, in case the bushing was not aligned exactly right or whatever, you know, there could be, it's just a place where there could be some additional error. So the idea here is let's bore it in place rather than just trusting that it's where it needs to be in that bushing. It's probably pretty darn close, but this will be a little bit better set up. So I'm going to come in here, we're going to take a little bit more out of the bore. I'm shooting for 0.731 is my final dimension, and I'm at 0.689 or so. We got just a touch over 40 thousandths that needs to come out of there, and I'm going to finish this. I actually have a reamer that I'm going to take it to the final dimensions, so I'm going to try to get it over here around 0.725 or so, and then we can just take that last couple of thousandths out with the reamer. So let's fire up the lathe and get rolling here. I've got the bore now within about 5 or 10 thousandths of my final dimension. We'll just come in here with the boring bar now, or excuse me, not the boring bar, but a reamer, and finish this thing up. That should give us a nice smooth finish, uniform finish on the inside. Now check this hole size. This is a gauge pin. This is a 731 thousandths, which is what I was shooting for in my final dimension. And yeah, that's a beautiful, beautiful fit. And let's see, this one here is a 732. And yeah, it's not going to go in there. So I think we hit our mark right where we wanted to be. So the last little bit we need to do here is just face this little bushing off flush with the casting. I purposely made it a little bit long so that we could fit it in place here. So let's see, turn that speed back up. We'll just come in here and do this real quick. Touch off on the casting itself, right there. So there's the bushing. Of course, on the other side, we got the side that's been counterbored out, oversized, just like it was originally. And this should fit right up on my shaft. Let's see. Yep, that feels good. That's going to work just fine. So now what I got to do is broach a keyway in here to go on this shaft. And I'm going to have to look. I may have to make a broach bushing to fit this. Let me see what I've got over in my collection. Hi guys, I got my broach bushing made. I did this, it's going to be in a separate video. I just decided that it was probably video worthy in its own. So if you want to watch that, it'll probably be coming out shortly after this video post. But the broach bushing, nice custom fit here, fits perfectly. And I want to line up the top of my keyway. There is a set screw. There's a hole right here that goes all the way through for a set screw, and I want this keyway to be lined up with the set screw, so that when I tighten that set screw, it's actually tightening the key on that shaft, and that will hopefully keep this thing from getting loose again like it did before and wallowing out. So I got my broach ready to go. This is my 3/16 inch broach. And make sure that's going to clear. We're good. Let's lube this up real good. And we should be ready to go here. Pass one is done. This requires a shim on the back side and a second pass to get it to full depth. So we'll take another pass through here. All right, that should be our keyway all broached out. All right, one keyway cut. Well, I'm back over at the mill again, and next thing I want to do here is I want to put a keyway between the bushing and the pulley itself. And to do that, we're just going to use a Scotsman's key here. So basically, this is just going to be a set screw. I'm going to drill and tap a hole in here. This is 1/4 20. We'll drill and tap that 1/4 20, and then I will screw this down right in between those two pieces, and that will just make sure that if this thing ever gets in a bind, that it doesn't start spinning on the bushing itself. So anyway, we're going to drill that with number 7 drill and tap it in there. Just going to come in here and spot that, give me a place for my drill bit to go. Number 7 drill bit for a 1/4 20. Put a little anchor lube in here to lubricate that as we go down. And I got a 1/4 20 hand tap here, and we'll just come through here and get this hole tapped in there. All right, blow that out and we should be good. All right guys, we're gonna go ahead and put this set screw in now and lock this in place. I've got some Loctite here. We're going to just put a little dab on there. That'll make sure this thing doesn't ever come out. And there we go. And that'll make sure that that bushing never spins. All right, last step here, guys. We need to extend this tapped hole here where the set screw is going to go down through there. And there was an existing hole in here, but it's not through the bushing. So I'm going to go ahead and drill and tap that as well. So I got an extra long, again, number 7 drill bit. This is 1/4 20. This is a long length one. When this pulley was made, they put the hole in the rim here just to put this in. So I'm taking advantage of that, and we're going to go right down through there. And hopefully get down in the bottom of that hole and drill that hole the rest of the way on out. And there we go, that's it. And now to tap it out, guys, this is what's called a pulley tap. That's the name of it, and it was for doing pulleys just like this. So this long shaft tap here. Tell you what, let me put a little anchor lube down in that hole. And we'll put some on the tap too. And we'll go ahead and extend those threads all the way through the bushing. The set screw that goes through here will also help keep that from ever spinning. It'll be like a pin going through the whole bushing and everything. So, and we are all the way through. See how we did. So there's my key that goes in here. There's the finished part there. We'll slide this up on. There we go. That was perfect. And set screw here. When I put this on for real, I'm going to have to take it back off. But when I put it on in the machine, that one's a little bit too thick. I'm going to have to get a thinner one, but I'll make sure we Loctite it. But just want to test fit here. Pulley looks like it is running nice and true. And I think we have had success, guys. This ought to do the job just right. Mission accomplished. We have our pulley all fixed up again. This should be a great improvement over where we started on this project. So this is pretty much ready to go back into the machine. I will do that in a separate video, getting this back installed and hopefully getting it all hooked up and going. But I think we knocked this one out of the park. We had great success on it. So anyway, that video's done, guys. That'll be a wrap. And with that, if you haven't already, please subscribe to the channel. Leave me some comments if you like. And we'll talk to you next time around.